to Science Fantastic with Professor Michio Kaku. Every week on Science Fantastic, we profile some of the most amazing developments in science and technology. And today, we're going to blast off to Mars. That's right, there's an astounding new probe that's being readied by NASA. And we're going to put a helicopter, get this, a helicopter on another celestial body in the heavens. With us today is Professor Jim Bell of Arizona State University. He's the president of the Planetary Society and the author of a number of great books, including The Hubble Legacy, 30 Years of Discovery and Images, and The Ultimate Interplanetary Travel Guide, A Futuristic Journey Through the Cosmos. So, Jim, glad you could be on Science Fantastic.
Well, thank you for having me on the show. It's great. It's just such an exciting time in space exploration, right?
Yeah, that's right. Well, let me ask you a question about your youth. When you were a kid, what first steered you in the direction of science and then astronomy?
Oh, it's a great question. Really kind of two things. I grew up in the northeast of the U.S. in a relatively rural place that I was fortunate to have pretty dark skies on clear nights. And my family bought me a telescope, a small telescope, and so I was able to, see the cosmos myself, and with some other nerdy friends in school, we were able to, watch the planets and the moon and comets and nebulae, and just really experience the wonders of the universe, through my own eyes. And as a kid, that was just hugely inspirational and exciting, and asking all the questions that we do about what's going on out there. That was one thing. And the second thing, and this is pretty common among many of my colleagues in my generation. I'm kind of a middle-aged guy. Maybe it's common for you too. I was inspired by Carl Sagan and his 1980 show Cosmos, which you may remember back in 1980, there was very little science on television. There were only three major networks, and PBS was it. And here comes this guy with a distinctive guttural New York accent and a tweed jacket. This professor is talking about space and astronomy and the planets, and he wasn't using jargon and lingo. He was talking like plain English, and I could understand it. And of course, Sagan was a visionary, and it was hugely inspirational to me as a young person, and many others in my generation.
Okay, and now you are president of the Planetary Society. So tell us a little bit about what is the Planetary Society.
Yeah, and that's kind of ironic, because the Planetary Society was founded in 1980 by Carl Sagan and Bruce Murray and Lou Friedman as a response to proposed enormous government funding cuts for space exploration. And so we've been around for that entire time, 40-year anniversary this year of the Planetary Society. It's the world's largest. Yeah, thanks. It's the world's largest public space advocacy and education organization, membership organization. We've got more than 50,000 people in many, many countries around the world. And we focus on, getting people involved, making people around the world feel like and actually be part of exploring our solar system and beyond. So we work on education, we work on advocacy, we work on projects. It's just a great organization, and hopefully you've got a bunch of members out there who are listeners, and a lot of listeners who might want to become members. It's a great organization.
And speaking about exploring the cosmos, let's just say a few things about the moon. I understand that there's going to be a new drive to put humans back on the moon. We have Elon Musk of SpaceX. He's readying his version, the Falcon Heavy. We have NASA itself with the SLS booster rocket capable of going to the moon. Not to be outdone, we have Jeff Bezos of Amazon with his new Armstrong rocket, apparently capable of also going to the moon. And not to be left out, the Chinese have the Long March rocket, and they want to put their flag on the moon as well.
Right.
So do you think, therefore, that we could be entering a new era where it's actually now fashionable to go back into outer space?
Well, I don't know about fashionable, but certainly becoming more practical and more affordable, right? Especially with more of these entrepreneurial so-called new space companies getting involved in building rockets and the amazing things that are happening with SpaceX and Blue Origin in terms of their launch vehicles and many others. So access to low Earth orbit and near Earth space, including the lunar environment, is becoming easier. It's never going to be easy, right? It's never going to be easy to get in a rocket and go anywhere, but it's becoming easier and less expensive, and that opens up more opportunities for exploration, more opportunities for commercial development, et cetera. And the moon is our testing ground for deeper space operations. Everybody's understands that the next big goal for NASA astronauts is to go to Mars. Astronauts around the world and other space agencies as well. The first people to Mars coming up in our lifetimes, maybe within 10 or 20 years. And here we have the moon, and we went to the moon in the 60s with the Apollo program. And we lost that capability with the loss of the Saturn V, the shutdown of that program. And so a lot of that's getting rebuilt, and it's a great place to practice deep space travel, deep space operations, relatively close to home, so safer than going out to Mars or asteroids. And it's also, there's some great science to do at the moon. The Apollo astronauts started that process, and learning about the moon teaches us about the origin of the Earth and the Earth-Moon system and other planets in our solar system. So it's a combination of just all kinds of factors, the technology, the more affordability, and the scientific goals that are pushing us to the moon and then onto Mars and beyond.
Well, you mentioned affordability, and back in 1966, I still remember that the Apollo budget to send us to the moon consumed 5% of the entire federal budget. Think about that. 5 cents of every dollar you paid in income tax went to the Apollo space program. And that was unsustainable. I mean, it cost $10,000 to put a pound of anything into near-Earth orbit. It cost about $100,000 to put a pound of anything on the moon. And it was unsustainable. But now we have reusable rockets, complements of Elon Musk and SpaceX. Some people think, therefore, that could really open up the heavens if the cost of booster rockets continues to drop, especially if they're reusable. What are your thoughts?
Yeah, no, absolutely.
Let's take a short commercial break. And after the break, it's on to Mars with the Perseverance Mars rover. Welcome back to Science Fantastic with Professor Michio Kaku. Well, once again, our special guest today is Professor Jim Bell of Arizona State University. He's the president of the Planetary Society, and we're talking about Mars. So tell us a little bit about Mars Perseverance. I understand that NASA wants to put a helicopter on Mars. That would be a game changer, right?
Yeah.
Being able to roam over the surface of Mars like a helicopter. Could you elaborate?
Yeah, so Perseverance is NASA's next Mars rover. It's going to launch next month to Mars. We'll land in February at a place called Jezero Crater, which is a big hole in the ground with a spectacular river delta that flows into it. So it was a place where there was a long-lived lake environment early in the history of Mars. Pretty spectacular place to explore. And we'll be looking for signs of evidence of ancient life on Mars that might be preserved in that rock record. And we'll be collecting samples with the Perseverance rover through a coring drill, make cores of rock samples and scoop up soil samples, put them in these little containers that are about the size of a cigar tube, up to 40 or so of them, and put them on the surface for a future mission to Mars to return them to the Earth. So it's the first part of Mars sample return. Pretty exciting. The rover is made out of 90% spare parts from the Curiosity rover that's on Mars right now, that's been on Mars since 2012, operating great. And that was to save money, to keep the costs as low as possible. But lots of different components and instruments on this rover compared to Curiosity because of that sample return goal. And there's a couple of tech demos on the rover. One is the helicopter that you mentioned. It's about a 4-pound solar-powered drone, basically, with a double rotor blade system that the blades are about 4 feet across. So it's a pretty good-sized drone. And the idea is just to do some test flights. There's a camera on the drone, and the rover will drop off the helicopter, back away, and then the helicopter will do a series of test flights to demonstrate powered flight in the Martian atmosphere and take some pictures, etc. It's not going to be really used as a guide or a scout for the rover because it really has a very limited lifetime because this is the first test. But you're right. If it works really well and they can validate the engineering behind it, then this kind of technology could be on future missions to Mars or other places. In fact, NASA picked a quadcopter to go to Saturn's moon Titan later in the 2020s. So this kind of technology is going to be more and more common in planetary atmospheric exploration.
Now, the atmospheric density of Mars is only 1% that of the Earth, and helicopters, of course, require a lot of atmospheric density in order to get off the ground. So wasn't it an engineering challenge to be able to create and engineer a helicopter that could work in such a thin atmosphere, almost a vacuum?
Not really, actually. I mean, of course, it's an engineering challenge to build anything to go into space, but the gravity is lower, so that helps, and the helicopter is very light. It's only about 4 pounds. So, while it's not going to be possible to fly helicopters that can carry people like on the Earth because the atmosphere isn't thick enough, it is possible to launch small drones, to fly small aircraft, drone kind of aircraft that are light and with a good wingspan. So partly the reason the blades are 4 feet across is because the atmosphere is so thin. But it's very light, and they've actually demonstrated this in very large vacuum chambers on the Earth, pumping them down to the pressures of the Martian atmosphere and demonstrating that the helicopter should fly just fine.
Okay, and also you mentioned the fact that it's going to be collecting rocks for eventual rock retrieval. In other words, rocks from Mars will eventually come back to the planet Earth. Now, some people say, well, what's the big deal? Because meteors from Mars have actually landed on the Earth in the past. So could you elaborate, how is it that we know that Mars rocks in the form of meteors were blasted out of Mars and actually landed on the Earth?
Yeah, there's something like 50 or so samples that have been found, many on the ice in Antarctica of Mars rocks on the Earth, just like there are rocks from the moon on the Earth. An asteroid or comet smashes into a planet like Mars or a planet like the moon and throws up a bunch of debris, and some of that finds its way to the Earth. And we know that those particular samples are from Mars because some of them have trapped atmospheric bubbles in them that match the atmosphere of Mars. What we don't know is where are they from. So we don't have any context, the geologic context, what kind of environment were they in, et cetera. They're kind of random samples, not even from the surface in most cases, but dug up from deep in the subsurface by the impact event. So we want samples that are well chosen by geologists and others through the rover of surface areas where we believe that water has flowed for long periods of time, sediments have been transported, maybe evidence of past biologic activity has been preserved in the chemistry, in the mineralogy, maybe even fossils, extremely low probability. We don't really believe that we'll find fossils. I mean, when you look at ancient rocks on the Earth that are 3-4 billion years old, this is well before organisms were forming fossils or forming hard shells on the Earth. So the evidence for early life on Earth is chemical, textural, mineralogic, isotopic, and we expect that might be the same case on Mars. So that's partly why we need to bring those samples back, too. We really want to study them in detail in the best laboratories on the Earth, because we can't transport those amazingly detailed, precise lab instruments, some of which are the size of, entire rooms. We can't get those to places like Mars yet, so we need to bring the samples back.
Now, some astronomers have speculated that our solar system is sort of like a gigantic ping pong game. because asteroids plow into Mars and blow rocks into space containing maybe DNA, who knows for sure. These rocks then land on the Earth. And therefore, we should also have Venusian meteors, lunar meteors, as well as Martian meteors. And they, in turn, probably had Earth rocks that landed on their terrain as well. And so some people have speculated that there could be a ping pong game between Mars, Earth, Venus, and the Moon, sharing different rock samples of which maybe DNA is a component. But this is a theory, of course. What are your thoughts?
Well, it's a hypothesis that is very, very difficult to test. Can life or complex organic molecules even survive those kinds of impact processes? Some scientists think so, others think not. There are experiments that are going on trying to look at the viability of terrestrial kinds of organic molecules under typical impact conditions. But you're right, and this idea goes back a century. The idea of panspermia, that the cosmos is seeded with life. It doesn't really solve the problem of where did life come from, right? I mean, if Earth life came from Mars, for example, where did Mars life come from? Well, maybe it came from somewhere else. Well, where did that life come? So we're still driven to try to find the answer. How did it all start, as well as are we alone?
Now, journalists obey the rule, follow the money. And astronomers apparently follow the rule, follow the water. And I understand that, most water on Mars is frozen. It's a very cold, frozen desert. However, underneath the ice caps, there's speculation that there could be liquid water lakes. So could you elaborate on the possibility that perhaps below the surface there could be deposits of liquid water?
Yeah, it's extremely likely. Mars is a terrestrial planet like the Earth, though smaller. So it gets warm as you go down because of internal heat sources. The core it may not be molten anymore because the planet doesn't have a magnetic field, but it was molten early in the planet's history, and it's still cooling.
Science Fantastic with Professor Michio Kaku, and this hour we're getting ready to go back to the planet Mars with the Mars Perseverance probe ready to go. It will have rock retrieval capabilities and a helicopter that could zoom over the surface of Mars. Now, Mars is still a mystery. There's so many things we don't know about the planet. For example, methane. Methane gas is found in your kitchen. It's a byproduct of decaying organic materials as well as chemical processes. But methane deposits have been found on Mars, and we are clueless to understand where they come from. So could you elaborate about the mystery of where is the methane coming from?
Well, first of all, it's a hypothesis that methane is on Mars. It's not been proven. There's extremely tiny amounts that have been detected in some measurements and not detected in other measurements. So it's really an enigma, and the scientific community that studies the Martian atmosphere and the Martian environment is in the middle of a really kind of a debate about whether the measurements are valid, whether we're seeing, for example, contamination from the rover on the ground making the measurement, whether we're just seeing uncertainty in the measurements, or whether we are actually detecting methane. But tiny, parts per billion amounts, really tiny amounts. And the European orbiter, which got to Mars recently, called the Trace Gas Orbiter from the European Space Agency, has a very sensitive instrument that's designed to detect methane in small amounts on Mars, and they haven't detected any. So lots of conflicting data. This is a great example of, the scientific community is in the middle of a big forensic mystery. Some evidence this way, some evidence that way. And, like forensics, it's going to take more clues, more evidence to tip the scales and the hypotheses one way or the other. So I wouldn't phrase it as strongly as you did.
And also, when you look at photographs of the surface of Mars, you see the remnants of what looks like to be riverbeds, seas. Some people even think that maybe there was an ocean the size of the United States once upon a time on Mars, but they're all gone. So here's the question. What happened to all the water on Mars?
Yeah, you're right. This is, one of the most amazing discoveries of the last few decades of Mars exploration is all that evidence that Mars was much more like the Earth early in its history. A thicker atmosphere, warmer temperatures, liquid water flowing on the surface, rivers, lakes, gullies, etc. Where did it all go? Well, NASA and other space agencies are trying to figure that out. The leading hypothesis is that early in the history of Mars, when the core was molten and the planet had a magnetic field and a thicker atmosphere, it was protected from the constant barrage of high energy particles from the solar wind, which can sort of slowly, like billiard balls, blast the atmosphere away over time. But the magnetic field protects a planet from that process. The Earth's magnetic field protects our atmosphere from much of that process. And then when the core of Mars cooled, because it's a smaller planet, so the core cools faster than the Earth's core, and that magnetic field got shut off, then all of a sudden 2-3 billion years ago, the solar wind can directly impact the upper atmosphere and drive off those molecules and break down those molecules. And it's a slow process, but it's had billions of years, and over time, the atmosphere gets thinner and thinner and thinner.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Professor Jim Bell of Arizona State University. He's the president of the Planetary Society. And so we're talking about exploring the solar system. And of course, one possibility that people have looked at over the last several centuries is the possibility of life on Mars. In fact, Carl Sagan, when he was a teenager, used to read the John Carter of Mars fiction, science fiction, and he was hooked. He thought that maybe one day he or his descendants would be able to roam over the sands of Mars and chase after Deja Thoris. Well, we have now doubts about all that. But, well, what are your thoughts? Any possibility that life could thrive on Mars, or maybe in the past? Or is it simply a science fiction and fantasy?
Yeah, Mars is the most Earth-like place in our solar system besides the Earth itself, and so it's been a focus of speculation in science fiction and science itself in terms of life. And what we've learned in the past 50 years of exploring Mars with robotic probes is that the surface itself is an extremely harsh environment today. Much colder, much thinner atmosphere, no protective ozone layers, so lots of harsh ultraviolet radiation hitting the surface. So very, very a dangerous and inhospitable environment for life as we know it, including people someday when we go there. We're going to have to protect ourselves against all of these things. But two things. One, if you go back in time, turn the clock back to when Mars had that thicker atmosphere, when it was much more Earth-like, although never really like the Earth, but much more Earth-like, then it was a habitable environment. There's water flowing on the surface, organic molecules, heat sources from volcanoes, impacts, and geothermal. These are what we need for life to have existed and thrived on the Earth. So the conditions were right, and that's why we go look at those ancient places like where the Perseverance rover is going. And secondly, if you just go down into the subsurface today, deep into the subsurface, maybe meters, tens of meters, kilometers, you protect yourself from the ultraviolet radiation. It gets warmer as you go down, and much of that ice that we see all over the planet in the near surface and on the surface could be melted, and there could be aquifers and underground water, which would be great environments for life on Mars even today. Simple life, microbial life. There's enormous volumes of microbial life on the Earth in the subsurface in those kinds of places. And what we've learned is it's not crazy to speculate that life could exist on Mars in those kinds of environments even today.
Okay, and also terraforming Mars has been a goal of the Mars Society, for example, and we've had them on the show. Even Elon Musk speculated that what happens if you detonate a few hydrogen bombs on the polar ice caps, you could melt the polar ice caps and water would flow on the surface of Mars again. Well, of course, the water would be radioactive, and I'm not sure you would want to drink it. Other people have proposed that far in the future, maybe solar satellites can melt the ice by beaming sunlight to the polar ice caps, thickening the atmosphere, allowing water to flow freely as a liquid on the surface of Mars. But of course, all this is pure speculation. But what are your thoughts?
Well, this is, I tend to be a pragmatist. While it's fun to speculate about the future, topics like terraforming are, while possible and imaginable, to do planetary scale engineering like that, they're in the far future. They're centuries to millennia in the future to turn an entire planetary environment like Mars into a more hospitable Earth-like environment. So I think, but in order to do that, we're going to have to we're really going to have to understand the environment that is there on the planet today. We're going to have to understand the potential resources that are there on Mars, how much water is trapped in the subsurface, how easy is it to extract oxygen from the atmosphere, what is the inventory of organic molecules on that planet. And we're starting that process with robotic probes, and it's going to take people to really get the answers in decades ahead.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Professor Jim Bell, and we're talking about exploring the solar system. Now, we mentioned before that billionaires are opening up their checkbooks and helping to sponsor some of these fantastic devices through SpaceX and Blue Origins. However, Google billionaires also want to jump in the game, and Google billionaires have been sponsoring the idea of mining the asteroid belt. Now, remember that when Thomas Jefferson, years ago, signed the Louisiana Purchase, he speculated that it would take 1,000 years to colonize the Louisiana Purchase. However, what happened? Gold was discovered in California, and bingo, all of a sudden the West was colonized within less than 100 years. And so some people think there could be another gold mine out there. Platinum-based metals, rare earth metals could be mined. And NASA at one point even had a mission to retrieve an asteroid. But, well, what are your thoughts about mining the asteroid belt and letting that pay for the bills?
Again, my thoughts are much more pragmatic than futuristic thinking about precious metal mining. These objects have very little gravity, so mining as we understand it really won't work, and so an entire new technology is going to have to get built, and that's going to take time. But while precious metals will be interesting at some point in the far future, I believe that the reason to extract resources from asteroids or other places in space is for use in space at those places and not really to bring that stuff back to the Earth. For example, the gold of the solar system is not going to be gold or platinum or other precious elements in the near future. It's going to be water ice. Water ice is, you can extract oxygen for us to breathe. You can extract hydrogen and oxygen to use as rocket fuel. You can use it as a shield against radioactivity. Enormous numbers of uses and practical uses for humans out there in the solar system. So I think looking for water on asteroids or water in the polar craters of the moon, places like that, water in the subsurface of Mars, that's the prospecting and mining activity that's going to dominate the next many decades and near future of exploring space and sending people into space.
Now, moving on, we have the moons of Jupiter and Saturn. Titan is an intriguing moon because it seems to have an atmosphere and possibly methane and ethane. And some people have speculated, and this is speculation, that in the future we'll use Titan as a gas station. We'll load up on methane by landing on Titan. Of course, you also need an oxidizer because you have to have a chemical reaction to stimulate it. But what are your thoughts about exploring the moons of Jupiter and Saturn?
Yeah, I mean, they're fascinating worlds out there, planets in their own right. Europa, the moon of Jupiter, has an enormous subsurface ocean that has more volume than all the oceans on the Earth, for example. Titan, it's known to have ethane, methane, propane in its atmosphere. It's not hypothesized. It's known. It's been measured. We've sent probes to the surface to measure it directly. So it's very much like what the early Earth's atmosphere was like before oxygen took over and completely changed the nature of our atmosphere and of life on our planet. So lots of great science reasons to go out there, but also great astrobiology reasons to understand the early history of the evolution of terrestrial worlds like those cold terrestrial worlds, but certainly planets in their own right with cores, mantles, crusts, interesting geologic histories, and in the case of Titan, the thickest atmosphere of any moon in the solar system, 1.5 times thicker than Earth's atmosphere. So, yeah, fascinating worlds, tough to get to, takes a long time. They're harsh environments. The radiation around Jupiter, for example, extremely harsh environment, so lots of technical and engineering problems, but also those places are calling to us to understand the history of life and places that could still harbor life in our solar system.
Well, what's also the progress of a NASA probe to Europa to send a submarine under the ice cover into the liquid water ocean of a moon of Jupiter? How's that coming along? I understand that at one point it was canceled and then delayed.
Well, it's never been. Thoughts? Yeah, it never officially has been started. It's all speculation and laboratory studies right now. What is happening is a mission will be launched called Europa Clipper. Will be launched later this decade to orbit Jupiter and fly by very close by Europa many, many times and map the surface at high resolution. We don't have a high resolution map of its surface, so we really don't know where to land a lander to drill into that ice. So the first thing that has to happen this decade is building up that detailed map of the geology and understanding the history of Europa, and then figure out where to land. And then maybe in the 2030s, we'll send a lander and really get down onto the surface, characterize that environment well, figure out how hard or easy is it really to drill into that ice. And the idea of a submarine or other submersible, I think, is many, many decades ahead, and certainly nothing official has been started.
Now, some scientists have speculated, and this, of course, is pure speculation, that because the moons of Jupiter and Saturn are more plentiful than Mars and Earth, that throughout the galaxy, perhaps, and this is, of course, a big perhaps, aquatic life forms are more common than terrestrial life forms. And perhaps we're the oddballs, we're the minority, that most of the universe, if there is life, is aquatic. Once again, our special guest today has been Professor Jim Bell, President of the Planetary Society, Professor at Arizona State University, author of The Hubble Legacy and The Ultimate Interplanetary Travel Guide. Good day.